Today is May 30th, 2025. Cell phones are truly amazing. They have changed our world so much. Many of us cannot imagine life without them. These small devices fit right in our pockets, yet they hold incredible power. They connect us to people far away. They give us information instantly. They entertain us for hours. It is a small miracle we carry daily. Think about your day. How many times do you use your phone? You might wake up with its alarm, you check messages from friends, you read the news on your way to work, you listen to music or a podcast. Perhaps you use it for directions or to pay for your coffee. The list goes on and on. Our phones are central to modern life. This constant connection is a big deal. Before cell phones, things were very different. To call someone, you needed a landline phone. These phones were stuck in one place. If you were out, you could not easily be reached. Long-distance calls were often expensive. Finding information meant going to a library or looking in an encyclopedia. Cell phones changed all of that. Now, information and communication are at our fingertips. We can talk to anyone, anywhere, anytime. This has made the world feel smaller. It has opened up new ways to learn. It has created new kinds of jobs. It has even changed how we form relationships. This little box of electronics is a powerful tool. It shapes how we live, work, and play. Understanding how it works is fascinating. So, what makes a cell phone work its magic? It is not just one thing. It is a collection of tiny, smart parts. These parts all work together. Let's peek inside this magic box. One of the most important parts is the brain. This is called the processor, or CPU. It thinks for the phone, it runs all the apps and commands, it makes everything happen quickly and smoothly. Another key part is the memory. Phones have two kinds of memory. One is like short-term memory called RAM. It helps the phone run apps smoothly. The other is like long-term storage. This is where your photos, videos, and apps are kept. Then there is the battery. This gives the phone its power. Without a battery, the phone is just a lifeless brick. Modern batteries are designed to last many hours. Of course, a phone needs to send and receive signals. This is the job of the antenna. The antenna is a very special piece of metal. It catches radio waves from cell towers. It also sends out radio waves from your phone. These waves carry your voice and data. Without an antenna, your phone could not connect. It would be isolated from the network. It's a crucial link to the outside world. Finally, we have the screen. This is how you see what the phone is doing. It is also how you interact with it. Most phone screens today are touch screens. You can tap and swipe to control the phone. The screen shows you pictures, videos, and text. It is your window into the phone's digital world. These components and others make your phone a powerful computer, a computer that fits in your hand. A cell phone needs to interact with us. It needs to take in information. It also needs to give us information. These are done through input and output devices. Think of them as the phone's senses. The most obvious input device is the touch screen. You tap on it to open apps. You type messages using a virtual keyboard. Your touch tells the phone what to do. It's a direct way to communicate your intentions. Another important input device is the microphone. When you make a call, the microphone captures your voice. It turns your sound waves into electrical signals. These signals can then be processed and sent. Many phones also use microphones for voice commands. You can ask your phone questions or tell it to set a reminder. This makes using your phone hands-free. It's like talking to a helpful assistant. For output, the screen is a major player. It shows you everything, but sound is also important. That is where the speaker comes in. The speaker turns electrical signals back into sound waves, so you can hear the person on a call or listen to music and videos. Some phones have very powerful speakers. They can create rich and immersive sound. This makes entertainment much more enjoyable on your device. Other sensors act as inputs too. The camera is a big one. It captures light to take photos and videos. This is a visual input for the phone. Accelerometers and gyroscopes sense movement. They know if you are holding the phone sideways or if you are walking. GPS receivers get signals from satellites. This tells the phone your location. All these inputs and outputs make the phone incredibly versatile. Cell phones were not always small and smart. Their journey is a fascinating story of innovation. The very first mobile phones appeared in the late 1970s and 1980s. They were big and bulky. Some were so large they had to be installed in cars. People often called them car phones. They were also very expensive. Only a few people could afford them. These early phones could only make calls. Texting or internet access was science fiction then. The first truly handheld mobile phone was the Motorola Dynatac 8000X. It came out in 1983. It was nicknamed the Brick because of its size and shape. It weighed about 2 pounds. It cost thousands of dollars. The battery life was very short, around 30 minutes of talk time, but it was a revolution. For the first time, you could make a call without being tied to a wire. This was a huge step forward. Through the 1990s, phones became smaller. They also became cheaper. New features started to appear. Text messaging, or SMS, became popular. Digital screens replaced simple LED displays. Different phone designs emerged, like flip phones and slider phones. This era saw the rise of companies like Nokia. They made phones more accessible to ordinary people. The focus was on better voice quality and longer battery life. These improvements made phones more practical for everyday use. The biggest change came in 2007. Apple introduced the iPhone. This was the first true smartphone that captured the public's imagination. It had a large touchscreen, it had a user-friendly operating system, and it had the App Store. This allowed users to download new applications. Other companies quickly followed with their own smartphones. Phones were no longer just for calls and texts. They became powerful pocket computers, changing how we connect and access information. Section 5. Talking to towers, the cellular network explained. How does your phone actually connect to someone else? Well, it uses something called a cellular network. Imagine a city or a large area. This area is divided into smaller parts. Each part is called a cell. This is why we call them cell phones. Each cell has its own tower. This tower is called a base station. The base station has antennas and radio equipment. It is like a local communication hub for all phones in that cell. When you make a call, your phone sends a signal. This signal is a radio wave. The nearest base station picks up this signal. The base station then connects your call. It sends the call through a wider network. This network links many base stations together. It also connects to the regular landline phone system. So you can call someone on a landline from your cell phone or another cell phone user far away. What happens if you move while you are on a call? For example, if you are in a car, you might move from one cell to another. The cellular network is smart. It handles this smoothly. This process is called a handoff. As you move to the edge of one cell, its signal gets weaker. The network notices this. It finds the base station of the next cell you are entering. It then transfers your call to that new base station. All this happens very quickly. You usually do not even notice it. This system of cells and base stations is clever. It allows many people to use their phones at the same time. Each cell can handle a certain number of calls. By dividing areas into many small cells, the network can serve a large population. If there were only one giant tower for a whole city, it would get overwhelmed. The cellular design is key to making mobile communication work for millions of users. It is a distributed system of connection. Section 6. Invisible waves, the science of radio communication. Cell phones talk to towers using invisible waves. These are called radio waves. Radio waves are a type of electromagnetic radiation, just like light or X-rays. But radio waves have much longer wavelengths. They can travel long distances. They can also pass through objects like walls. This makes them perfect for communication. Your phone has a tiny radio transmitter and receiver built into it. This is part of its antenna system. To avoid confusion, different calls use different channels. Think of it like lanes on a highway. Each call gets its own lane. This is managed using frequencies. Radio waves can have different frequencies. The frequency is how many waves pass a point in 1 second. Your phone and the base station agree on specific frequencies to use. This prevents your call from mixing with someone else's call. It keeps conversations private and clear. When you speak into your phone, your voice is sound energy. The microphone converts this sound into an electrical signal. This electrical signal then needs to be put onto a radio wave. This process is called modulation. The radio wave acts as a carrier for your voice information. There are different ways to modulate a signal. For example, AM radio changes the amplitude or strength of the wave. FM radio changes the frequency of the wave. Cell phones use complex digital modulation techniques. The cell tower receives these modulated radio waves. It then demodulates them. This means it separates the voice information from the carrier wave. The voice information is then sent through the network. The process happens in reverse at the other end. The recipient's phone receives radio waves, it demodulates them, and the speaker turns the electrical signal back into sound. All this happens almost instantly. It is a fast dance of waves and information. Section 7. The phone's brain processing signals and staying connected. Your cell phone is more than just a radio. It is a very smart computer. Its brain, the processor, does a lot of work. When you speak, your voice is an analog signal. This means it is a continuous wave. Computers work with digital information. Digital information is made of ones and zeros. So your analog voice signal must be converted. It becomes a digital signal. This is done by an analog to digital converter, or ADC. Once your voice is digital, the phone's processor can work with it. It compresses the digital voice data. This makes it smaller, so it uses less space on the radio waves. This allows more people to share the airwaves. The processor also adds error correction codes. Radio signals can get distorted by noise or interference. These codes help the receiving phone fix any errors. This makes your call clearer. It is a clever way to ensure quality. The processor also manages the connection to the network. Your phone is constantly talking to the nearest cell tower. Even when you're not on a call, it tells the tower it is there and ready. This is called registration. The phone also listens for signals from the tower. These signals tell it about the network status and about incoming calls or messages. This constant communication keeps your phone connected. When you want to make a call, you type a number. The processor takes this number. It sends a request to the cell tower. The tower checks if the number is valid. It finds a path to connect your call. All this involves complex software and protocols. The processor runs this software. It handles all the communication rules. It is like a tiny, very busy traffic controller. It makes sure all signals go to the right place and that your connection stays strong. Section 8, Everyday Wonders, Cell Phones in Action. Let's think about some real-life examples. These show how amazing cell phone technology is. Imagine you're lost in a new city. You pull out your phone, you open a map app. Within seconds, a small dot shows your exact location. How does this happen? Your phone has a GPS receiver. GPS stands for Global Positioning System. It receives signals from satellites orbiting Earth. By listening to signals from several satellites, your phone can calculate its position. This is a wonder of coordination. Consider sending a simple text message. You type your message, you hit send. It seems so easy. But a lot happens behind the scenes. Your phone converts the text into digital data. It sends this data as radio signals to the nearest cell tower. The tower sends it to a short message service center, or SMSC. The SMSC then forwards the message to your friend's phone. This can happen even if your friend's phone is off. The SMSC will store it and deliver it later, all in just a few seconds. What about browsing the internet or watching a video online? This uses mobile data. Your phone connects to the internet through the cellular network. Technologies like 4G or 5G provide fast data speeds. When you click a link, your phone sends a request. This request travels through the cell tower. It goes to the internet. It reaches the server where the website is stored. The server sends back the data. Your phone receives it and displays the web page. This complex journey happens incredibly fast. Even taking a photo involves advanced tech. Modern phone cameras are very sophisticated. They have tiny lenses and sensors. When you take a picture, the sensor captures light. The phone's processor then works hard. It processes the image. It adjusts colors and brightness. It might even use artificial intelligence. This AI can recognize faces or scenes. It helps to make your photos look better. All these everyday actions rely on the complex workings we have discussed. They are small miracles we often take for granted. Section 9, the next connection, peeking into the future of mobile. The story of the cell phone is far from over. Technology keeps moving forward. So what does the future hold for these devices? One big area is faster networks. We have moved from 1G to 5G. 5G offers very high speeds and low delay. This opens up new possibilities. Think of smoother video calls, or playing complex online games on your phone, or even remote surgery using robotic arms controlled over 5G. The speed itself enables new applications. Scientists are already thinking about 6G. 6G aims to be even faster. It might use higher radio frequencies It could allow for holographic communication. Imagine having a 3D video call with someone. It would feel like they are in the room with you. 6G might also integrate more artificial intelligence. AI could manage the network more efficiently. It could also make our phones even smarter personal assistants. The goal is always more seamless and powerful connection. The phones themselves will also change. We might see new designs, perhaps more foldable phones or phones with screens that can roll out. Some researchers are working on flexible electronics. This could lead to phones that can be bent or stretched. Battery technology will also continue to improve. We all want batteries that last longer and charge faster. Maybe one day our phones will charge wirelessly from the air around us. That would be a true game changer. Beyond hardware, the way we use phones will evolve. Augmented reality, or AR, could become more common. Your phone screen could overlay digital information onto the real world. Imagine looking at a street and seeing reviews of restaurants pop up, or pointing your phone at a plant and learning its name. Phones will likely become even more integrated into our lives. They will connect to more devices in our homes and cities. The journey of this pocket miracle continues, promising even more amazing connections.